Well, hello there. So in this video, we're going to take a look at extra practice module 65. So this one is all about game theory and how we would kind of model what happens to oligopolists when they use that as their way of determining what their actions ought to be. So the first problem for check your understanding number one gives you a payoff matrix, and it says those are utils. And so you have two players, and I'm just going to redraw this payoff matrix. And it says build a missile and don't build, right? Build and don't build. And we have Nikita Khrushchev and Margaret Thatcher, it looks like over here. So, and so we have -10, -10 if they both build. They both get 0 if they both don't build. If Margaret doesn't build, but the Soviets do, that's bad for her. And oh, that's 8. That's 8. I can't read. 8. And that's 8 and -20. And I guess that's because you get an advantage if you have nukes and the other side doesn't or something like that. So, okay, so, and then there's ABC that we'll look at in just a second, but let's go ahead and solve this problem. If Nikita builds a missile, right, what should Margaret do? She could either get -10 by building or -20 by not building. She should build the missile. And if Nikita doesn't build, and she builds, then she gets 8. But if Nikita doesn't build, and then she doesn't build, then she gets 0. So she should build, right? And so we can kind of see we're comparing -10, -20, and 8 and 0. And so she's always going to build the missile. Now, from Nikita's perspective, right, he knows that. So he can either build and lose 10, or he can not build and lose 20. So he's going to build the missile. And if he chooses, right, if she chooses to not build, which, who knows, she might, he could get 8 or 0. Well, he would prefer 8. So we can see here they both have a dominant strategy to both build the missiles. And so we would say, A, identify any Nash, and we would say build, build, and explain why they exist, because we would say maybe both have a dominant strategy to build. Dominant strategy to build. And for part B, we can say which set of actions maximizes the total payoff for Nikita and Margaret. And this would just add the two numbers together, right? And you can see that, you know, if we end up here, that's -20. If we end up here, that's -12, -12, 0. So don't build is actually the best option. But they're not going to end up there. And why is it unlikely that they will choose the payoff maximizing set of actions without some communication? Because they both have a dominant strategy, right? We could just say that. They both have a dominant strategy to build the missiles. And that's actually, you know, another thing that game theory is used for is modeling political science and decision-making about those sorts of things. Let's take a look at number 2. Number 2 says, for each of the following characteristics of an industry, explain whether it makes it more likely that they will play non-cooperatively rather than engaging in tacit collusion. And so part A, each oligopolist expects several new firms to enter the market in the near future. And so that would be non-cooperative. And the thing is, because too many firms to cooperate, right? If you have all these new people coming in, it's going to disrupt kind of too many firms. Let me zoom out just a little bit here so you can see. It's going to make it too difficult for them to cooperate and kind of develop that sort of repeated behavior that they talk about in this module. Part B says it is very difficult for the firm to detect whether another firm has raised output. And what that's saying is it's hard for a firm to know if the other firms have cheated. And so that means they're less likely to cooperate as well, because they won't know if others cheat. Right? And if others are cheating, then you're going to lose money. And so, you know, that would make you less likely to cooperate in that case. So, part C, the firms have coexisted while maintaining high profits for a long time. So that kind of tells you that it's stable and it allows them to kind of predict each other a little bit. It's more likely for them to collude. And we know that collusion doesn't necessarily mean forming a cartel, but we know that it means maybe they're going to respond to each other and that sort of thing, you know, so that there could be non-kind of explicit kind of collusion, which we call implicit collusion, or tacit collusion is another way to say it, tacit collusion. Let's take a look at these multiple choice questions. These are going to appear on a quiz. So, number 1, each player has an incentive to choose an action that when both players choose it, make them both worse off. And that's actually what we had up here, right? And so we call that a prisoner's dilemma, B. the fancy name for it. And there's several examples in the book, and I think there's a multiple choice question too. What types of oligopoly behavior are illegal? Tacit collusion? No, that's not. Just kind of responding to each other and kind of tacitly colluding, that's not illegal. Cartel formation, that's illegal. You can't like sit down, draw up a contract. And tit for tat is a strategy where you play and you kind of play as the other person. Whatever they did, you play that. That's what tit for tat is. So that's not illegal either, just cartel formation. So that's B. Number 3, a situation in which each player in a game chooses the action that maximizes their payoff given the other actions, ignoring the effects on the payoffs received by others, is known as, that's the idea that when each player is doing it and ignoring the effects on the payoffs received by others, that's what we say is a Nash equilibrium, right? You know, where you choose your own payoff and you don't care about what the others are going to end up with. That's what that one is. So C. And number 4, all right, hang on, I'm trying to read. In the context of Thelma and Louise story in the module, suppose Louise discovers Thelma's action before choosing her own action. Oh boy, if she does. Okay, based on the payoff matrix, Louise will. And so we can kind of read through this and just kind of understand what's going to happen here. So if we know that the optimal is that they both don't confess and they both keep their mouths shut and they both get a 5-year sentence. Now, if we know that Thelma's action, if like Louise knows what Thelma's going to do, how will that change? So we'll think about, let's Louise, right? If Louise knows that Thelma's not going to confess, what should Louise do? Well, Louise can get 5 years by not confessing, or she can confess and get 2 years, right? So which one should Louise do? Well, she should confess and get only 2 years. And what about if Louise knows that Thelma is going to confess? Well, Louise could not confess, keep her mouth shut and get 20 years, or she could also confess and get 15. So Louise is always going to confess. It doesn't matter, even if she knows what Thelma's going to do, it doesn't matter if she's always going to confess. And actually both parties will do that. So we have here A, confess whether or not Thelma confessed. Number 5, well, that's the air moving around this. Oh my goodness. Which of the following, that's what happens when you're recording in a utility closet. Which of the following is true on the basis of the payoff matrix provided in question 4? Louise has no dominant strategy. Well, neither of these are true. They both have a dominant strategy to confess. So we'd see both Thelma and Louise have dominant strategy. C, there we go. Let's do free response number 2. Take a look here. Draw a correctly labeled payoff matrix illustrating the following situation. 2 firms from A, from B, high, low price. Okay. So high, low, A, and B. And it says if one firm charges a high and the other a low, the firm charging the high price will earn low profits, while the one charging the low price will earn high profits. If they both charge high, both earn high profits. If they both charge low, they both earn low profits. Okay, so if they both go low, they both earn low profits. So let's just say like 2 and 2. And if they both go high, then they both get, let's say 10 and 10. And what if A goes low and B goes high, then the firm charging the high price will earn low profits. So we'll say maybe 1, and we'll say here 15. And the reverse is true up here. If B goes low and A goes high, then we'll give them 1 and 15. Okay. And it doesn't say that we need to solve it. So that's a fairly straightforward one. I'm going to go ahead and solve it now, but that's just because I made up the numbers and now I'm curious what will happen. But otherwise, hopefully you guys learned a whole lot from this, and I'll see you next time. I'm going to go ahead and solve this though. So if you want to stick around and see how it works. So A, if they think B is going to go high, then A will go low and get 15. If B goes low, then we'll go low and get 2. And likewise, that's also true. If B thinks that A will go high, then B will go low and get 15. And if B thinks A will go low, which they will, then they should go for 2. And so they both have a Nash equilibrium in low. Well, of course they do. All right, see you next time. Bye now.